Alright, so today we are talking about reflections, which are transformations that create a mirror image or flip over a line. So here's our rule for the reflection across the x-axis. There are reflections across the x-axis, reflections across the y-axis, and reflections across any given line on the graph. Horizontal, vertical, slanted, could be any line. Alright, so what we're doing when we reflect across the x-axis is we are simply changing the sign of the y value. Fill that in. Changing the sign of the y value. So when I change the sign of the y values but leave the x values the same, it causes a flip. So here we have reflections across the x-axis. This is the same one or similar to the one that's on your paper, on your worksheet. Okay. So we're taking, let's say, the a value. The coordinates of the a value are 4, 7. So what are the new coordinates of a prime? There you go. 4, -7. There wasn't any work. There was no work. It was just understanding a rule. Just knowing the rule. Alright, so we can do the same thing for B and C. So what is B prime? Did the x values change?
7, -1.
Okay, good. C prime?
1, -1.
Yep. Whoops. That's it. Simple. So there's your reflection, an example of a reflection over the x-axis. Okay, let's go to the next one. Okay, so here's some more examples. Reflection across the x-axis. So on your paper, go ahead and do these on your own, and then I'll call on certain ones. Okay, so we can see our results. Very simple. We just change the y values. Okay, the second reflection rule is reflection across the y-axis. Now understand, the y-axis is our vertical axis. So if I had a rectangle over here on the right side of that y-axis and flipped it, it's going to be over here. Okay, so did I change the x value or did I change the y value?
You changed the y. I mean the x.
The x. So change the sign of the x value. So there's a lot of opposites going on. When we reflect across the x-axis, we change the y. When we reflect across the y-axis, we change the x. Opposites. When it comes to reflections, you're changing the signs of the opposite value. So, the original was whatever xy was. The new one is going to be -x, y. Got that? Alright, so here's another example. We're going to take our x values and change their signs. Because look, this was 4 for the a value. A prime is -4. But the y value did not change. It's still on the same level of y. It's up 1, 2, 3, 4, 5, 6, 7. It didn't change. So, what is a prime, Jatori? Alright, what is B prime, Ty? Good. Okay, what is C prime, Austin? Yep. Very simple. Okay, following the rules. Following the rules. Alright, Matt's all about the rules. Okay, here's another set of examples. Go ahead and do these on your own. You already done with those? Everybody already done with those? Okay, Chris, what is H prime? Good. Up. -1, 2. That's right. Because we're changing the x value. All right. Kari, what's A prime?
3, -5.
Good. And then T prime, Jeremiah?
-4.
Good. -4, negative. Did you say -1? Yeah, you're right. All right. So that's that. Okay, the third reflection rule. There are several of these rules, right? And again, I'm going to let you have access to these rules. I'm going to let you use this on your quiz. Look, I want y'all to move on to the next class. All right. I want you to move on. If you take care of your business, get your notes, and you use your notes and you pass the test, good for you. All right. We're moving on up. So, look what happened. We flipped. We changed them. We swapped them. When I reflect across the line y equals x. All right. Now here's my y-axis. Here's my x-axis. The line y equals x is this line right here. Y equals x. It's that slanted line that has a slope of 1. This is actually what we call the parent linear function. If you look over here, here it is. The parent function. The parent function is where all the linear functions come from. So here's the parent linear function. So the rule for flipping across the line y equals x is to swap the values. So if this had the coordinates of 4, 2, then this has the coordinates of 2, 4. Okay? So it's not that complicated. So we're going to swap x and y. Now, if you had to remember all these by memory, it might be a little bit challenging. All right? But if you don't have to remember it by memory, that's double negative. All right, it's redundant. If you don't have to memorize it, it's pretty easy. All right, so let's go on and look at some examples of this one. This is not really an example. It's not something we have to do. We just are looking at it. Notice how the coordinates switch places. So B was -3, -1, whereas B prime is -1, -3. We just swap them. So the left 3 down 1. This one is the left 1 down 3. And you can see that happens with all of the coordinates. Okay, so let's use the rule. Do this one on your own. Okay, so B prime, Chardonnay. Good. Okay, A prime, Arvion.
2, -8. No.
You're getting ahead of yourself. It's -2, 8. Just swap them. Don't change their signs. But guess what? You gave us a preview of what we're about to do. T prime. Back to Marlon.
13, 9.
Good. All right. So there you go. So that's reflection across the line y equals x. All you do is swap them. Okay. This is what Arvion just said. Reflect across y equals -x. Okay, this is our coordinate plane. The green line is the line y equals -x. It's got a negative slope. Okay, it has a negative slope. The slope is -1. All right, what we're going to do is we are going to swap and change the sign, both signs. Swap and change both signs. Now, this can be a little confusing. What I recommend is that you change both signs and then swap them. Now, what rule is this? When we reflect across y equals -x. This is our fourth reflection rule. So again, if you had to memorize these things, I've always let my students have a little index card with the rules on it or use their notes or whatever when it comes to this stuff. Okay, so that's not new for me. That's not something I do. That's just for y'all. It's something I've been doing. All right, but it's still, I still have students that struggle with this because they don't use the rules. Similar. All right. Okay, so reflection across the line y equals -x. These are the values. We need to find A prime, B prime, C prime. All right, Jatori, what do you get for A prime?
-6, 4.
-4. Change both signs and then swap them. You'll know what the rule is. You'll know what to do. It'll say reflect across the line y equals -x. So then what do? You look for it. You look for the rule. And then you just do what it says. All right. Let's see. Ty, what do we do for this one?
No, -2, -4.
There you go. Good. And Kari?
-2.
Okay, very good. Very simple. All right. Let's move on. Okay, here's some more examples. So, let's go Austin. W prime.
-21 and -13.
Yep. Okay, Princess.
-9 and 2.
Good. Okay, Jeremiah.
24 and 17.
Good. Okay, excellent. Okay, we're at the end. Lines of symmetry. Now, how many? A line of symmetry is a line that we would use to cut something in half, basically, or to do a reflection. In this case, this object is a triangle, and it's what we call a regular triangle or an equilateral triangle. And it has how many lines of symmetry? In other words, how many lines would it take to cut this thing in half? How many different ways can I cut it in half?
One. Right now.
Right down the middle? That's one. What else? That way. What else?
I don't like that.
There you go. 3 lines of symmetry. Okay? 3 lines of symmetry. Well, if all 3 sides are the same length, this is a equilateral triangle, then there would have to be 3 lines of symmetry. I got 3 sides, right? Cut each side in half. Okay, what about this oval? It's like an egg, but it's not. It's the same at the top and the bottom. Huh? 2. 1, 2. All right. Now, if it was a circle, how many would you have?
2. I mean 1.
Think about a circle.
What did I say?
Let me see if I can get a little circle diagram on here. I don't know where my circle diagram is. Here we go. All right, here's a circle. All right, there's a circle. Okay, so how many lines of symmetry?
2.
I know you're gonna have this one and this one, right? Oh, that's bad.
Oh, I got 4.
4.
Right there, right there. What else? Think about a pizza.
Yes, I was thinking.
Can you cut a pizza into as many slices as you want?
Yeah.
Now, you can't physically do it to infinite slices, right? But theoretically, there are infinite lines that are lines of symmetry for a circle because it's the same all the way around. All right? So there are actually infinite lines of symmetry for a circle. All right? How many lines of symmetry?
5.
Yep. 1, 2, 3, 4, 5. How do we know it's got 5? Why would we automatically know it's got 5?
Got 5.
It's got 5 points.
Oh.
Because it's a star. You got 1, 2, 3, 4, 5. It's kind of like a pentagon. If I were to finish this, kind of connect some dots here. It's a pentagon. Okay? So a pentagon, regular pentagon, has all those lines of symmetry. Okay. Alright, so here's a little bit more that the packet did not have. So I want you to, these 2 problems are reflecting across a specific line. Now the line x equals 1 is a vertical line. You say, wait a second, vertical is y values. But if my x value doesn't change, if x is just equal to 1, that means the only thing that could be changing are my y values. So the line x equals 1 is actually this line right here. So draw a vertical line at x equals 1 on one of your graphs. So in other words, just go over 1 unit and draw a vertical line. So anytime you have x equals a number, it's a vertical line. If you have y equals a number, it's a horizontal line. So I got a vertical line here. So I want to reflect across this line x equals 1. So go ahead and do the coordinates of this triangle. Go to the right 2 up 2, right 3 up 4, right 5 up 3. Do those coordinates.
Marlon Jackson, we have to go to the front.
All right. Let me write you a note. Okay. So when we reflect this thing, we're going to count. So I see that both of these points are 3 units above. So I need to go straight down so that the reflections are 3 units below. And then this point is, I did that wrong. No, I did that right, sorry. This point is 1, 2, 3, 4, 5 units above the blue line. So it needs to be reflected 5 units below the blue line. Once you have that, you can connect the dots. Oops. And there's your reflection. Again, we're not reflecting across the x-axis. We're reflecting across the line, the given line. And when we reflect across a different line, horizontal or vertical, we got to count. That's all there is to it. So again, remember that if we reflect across x equals a number, it's a vertical line. Reflecting across the vertical line, like this. And if it's reflected across y equals a number, you're reflecting across a horizontal line, or up and down. Okay, the last set of examples here. We want to find the line of reflection. In other words, we didn't have to do any work. The work's already been done. These figures have already been reflected. We have to find the line that they are reflecting across. Very simple. It's all visual. Okay, so I look at these two figures. I see they are mirror images of each other. Find the line that is directly in between those. Right here. Alright, and then count over. However many that you went over. How many did we go over? Well, from the origin. 1, 2. So is this vertical or horizontal?
Vertical.
It's vertical. And what do we say? For a vertical line, it is x equals a number. But I went over 2 units. So it's x equals 2. So there's my line of reflection. Vertical line, x equals 2. Okay? So for this last one, we got to look for the line that cuts this directly in between the two diagrams. So where would that line be? Somebody come up here and put it on the board. Somebody. Come on. Come on, somebody. First man up. Let's go. First woman up. Man or woman. Yeah. Come on. Right. Now think about where they are now. You got to figure up here, you got to figure down here. You want a line that's directly. Got it?
So what do you mean?
Yeah.
Yep. That's it. So finding that line is the first thing. Then you have to actually name that line. So what is the name of this line? Well, it's horizontal, so I know it's got to be y equals 3. Absolutely. So you just see where it crosses the y-axis, and that tells you the number. Crosses at 3. You're done. Pretty simple stuff. Now we've covered everything we pretty much need to know about how to do reflections. We have learned how to use the rule. We have learned how to write the rule or figure out how to do it on the graph. And now we've figured out what line of reflection we're actually using when they give us the graph.